Hello, everyone. We'll just give this a couple of seconds to see if anyone else wants to join, but thanks for joining us today for Feature Friday.
All right. Well, hello everybody. And Holly, if you're good, I might just dive in then.
Yep, sounds good. Let's go.
All right, sweet. Well, thanks for joining again. Anybody who has questions, welcome to interrupt me. I much prefer to do these things dynamically. My name's James. I've probably met some of you, if not all of you, before. I work in the business development side of Giraffe. I love our product and am just growing more and more amazed by it every single day. So what we're going to go through on this call is a deep dive into our new terrain function. And terrain is a complicated one. It's typically when you've worked with Giraffe, you will have worked with it on the two-dimensional plane, assuming the world is a perfect sphere. And but what we're going to look at today is the world's not a perfect sphere. It's filled with all sorts of changes in topography. And when we build a site or a proposed development, often a make or break part of that development is how much soil do we need to move, or that master plan, or whatever it might be. So I'm going to focus on Sydney because Sydney is wonderfully hilly, and but it does also illustrate where sea level is. So it's a nice place to demonstrate the feature set of terrain. If there are questions about other features in Giraffe, let's hold those to the end, but we're going to have plenty of time to cover all sorts of things. So I'm happy to go any which way after terrain. If there are terrain questions, let's address them head on whilst I'm demoing. Okay, so you're probably familiar with the first few steps of Giraffe, which is setting up your project. And the thing that defines your project is the project boundary. As I'm in Sydney, I actually want to add in some Sydney data layers just to get my bearings. So I'm going to go add data layer. I'm going to bring in the New South Wales cadastre. Cadastre is the Australian word for parcels. Some parts of the world use it. It's not Australian, but it is today. Cadastre. What else should we bring in, Holly? Let's bring in zoning, height of building. These are all just vector layers that are coming from the New South Wales digital twin. If you are in the US, which I think most of you are, there's tons of these data layers in your local municipality sitting in a GIS repository. And if Giraffe hasn't already added them, you can just hit the big orange, create your own button, and add either an Esri server or a vector of some kind, or non-vectors. So let's put that to the end if you want to talk about them. I'm going to pick a site that I think is relatively hilly, which is this park. So I'm going to draw my boundary and right click on the site. We'll see this cadastre set here. Lets me set the boundary exactly to the cadastre, so I don't have to stuff around with it too much. I can see the size of the site. And I am in Imperial, so I'm just going to change it to be in metric for the purposes of the recording. Okay, so I've defined my boundary, and if I turn off all the data layers, you'll see it just beautifully sitting there around this massive park. And the park is actually going to be very flat, so this is probably a terrible example, but I'll move the site in a minute. When we come over to the terrain tab, you'll notice this is new now on the right-hand side. And if you're following along in your Giraffe browser, you can hit the terrain button. And I'm going to go through this quite technically so that we can get an understanding of what each of these features does. When you hit the big enable terrain button, the first thing it does is it draws or it visualizes the terrain, the actual topography. And you'll notice it's in 3 dimensions. It's at its real elevation. And you can see the high point of the site's back here, and it goes down to this bowl at the bottom of the cricket pitch. Now, it's useful to see it at its relative height, or its real height, I should say. But often when we're working with a data set in 3 dimensions, it's easier to project it down onto the 2-dimensional plane. So if I hit drop, it takes it from its real elevation and puts the lowest point at the ground level of the 2-dimensional plane. It makes it much easier for me to deal with it, so I'm not editing something in the sky. So let's turn it off for a second. I want to just draw some geometries. Typically when we're in Giraffe, we can jump in here and say, we'll build some apartments, and we might want to build a, something interesting like a park with some trees around it, and potentially, I don't know, subdivision here. I'm not going to win any design awards for this particular project, but there we go. We've got some elements that we can work with. So when we go back to terrain, and I turn it back on, it's going to project all of those elements onto the 3D terrain. Now, if they're 2-dimensional elements, you'll see it drapes it beautifully over the landscape, which is nice. It doesn't necessarily, because we're putting a park here, we don't necessarily have to have it flat, so it's draping it over. But where it is a building typology, it will either cut or project properly. And you can see the apartments here are elevated above the topology. So I'll come back to this in a minute. Okay, so let's also then experiment with the other 2 buttons here so we know what they do before we move on. Clip to site boundary. If I turn that off, you can see I've got this wonderful ability to see much more terrain surrounding my site. If you have features outside of your project boundary that you need to work with, that could be very useful, and just getting some context can be useful as well. So I'll turn that off just to keep it locked to the site boundary. And then the other one, if you want to view the terrain but have your features on the 2-dimensional plane, you can do that as well. So I'm not sure particularly what the use case is there, but that's part of the functionality that we've added. Okay, so now we want to do, other than just visualizing what's there, we want to do some math. We want to be able to understand if we level out this building, are we going to be filling in over here, or are we going to be cutting down here? And the same with these guys over there. And if we're going to do that job, how much soil are we displacing when we do that? So to create cuts and or fills in the landscape, there is a new usage type when you have terrain enabled that is down here in the landscape features, and it's called building pad. So the first building pad I'm just going to draw is around my residential building. And it uses the polygon tool, so I need to close it. But you can see as I close it, now we've got this flat building pad. And that building pad has extruded out from the terrain a fill on this side, and I don't think any cut on this side, maybe a very small cut. But importantly, it's doing the math for us. So you can see it's cutting 1,200 cubic meters of soil over here, and it's filling 10,000 over here, or 9,200. So the total volume of soil that's displaced is 8,000. We're going to need to truck in 8,000 cubic meters of soil to make this work, which is a lot. So we can play with where it sits in the elevation and try and understand what the optimal configuration is. And Giraffe should solve for optimal, but it can be helpful to play around with it. You can see here I'm sinking the apartment building down to the depths of Hades, which is very fun. So just being able to play with it can help us identify often where the optimal spot is, and that can be different across different parts of the project, depending on what else is going on. So the algorithm will solve for that one building, but not necessarily for the entire site. So I kind of like this raised look, and then I like the park flowing down this sort of hill. So I'm going to bring the park up here, and I won't change the cut and fill there. I should mention as well, importantly, when you are doing this kind of cut and fill work, the angle of repose is very important. So if I go back to the building pad, you can see it's setting it at default for 45 degrees. But if I lower that down, then the way that algorithm solves is flattening out this hill here, which is not particularly helpful from a cut and fill perspective, but it's much better from a usability of the land. If you're doing retaining walls and industrial projects, then you'll probably set this at 90 degrees, and then you'll need to reinforce it. And you could build a usage called retaining wall and reinforce it straight down there. And that's getting complicated. So let's put it at 45 degrees and leave it. So that's building pad number 1. What's happening is we're cutting 300 cubic meters of soil. We're filling 13,000 cubic meters of soil. And that means that we have this delta that we need to deal with somehow. Now, every site has multiple considerations. This particular one, we're building townhomes over here, or row homes more realistically, and they need to be cut. So let's build a second building pad. And I, again, will just loop our building pad around townhomes. And this time, it's suggesting that we cut significantly on the back. And you can see what the app is doing is it's taking our cut number 1, or I should say it's predominantly a fill. Cut number 2, on the other hand, is it requires us to fill. Oh, sorry, it's giving us a surplus of 7,800. So we actually are now offsetting our big fill up here, which means we've got a delta of 5.5. So this can be really fun and powerful as you're experimenting with different solutions. And as I move this building pad around, that delta will move with me, which can be really helpful for when we're problem solving the optimal placement. So that's the raw mechanics of the terrain app. And it would be really powerful even if it stopped right there. But I want to go one step further and say, okay, how do we then include this in our pro forma? Because obviously being able to understand what our cut and fill is one thing, but what that means in terms of cost through to my pro forma is extraordinarily helpful. So the geniuses in the Giraffe dev team has made all of those expressions available to us within analytics. You're probably familiar with some of our templates. I pop into the rental option feasibility. There's all sorts of costs that we're considering: the hard cost to build, the soft cost to design and get finance, et cetera, a big contingency, but we don't have any site works in here. And our site works, we're just going to very crudely apply a price per dollar of soil that we need to truck into the site. If you want to go more granular, we can do that too. So let's add a new calculation. And I'm going to search for the properties that are related to cut and fill. So if I type cut, you'll see I've got the option to get either my cut volume from all of my geometries and sum them together. So let's do that. Say total cut equals sum of A. Total cut. It's in cubic meters. And it applies to everything. So we just hit save. Okay, there's our cut volume. I really should create a new category here. We'll call this cut and fill. And I'll take this and apply it down to that particular category. All right, then we'll go total fill. And it's also in cubic meters. Okay. And it equals fill. So you can see I'm considering them separately here, 6,000 and 16,000, but it's taking the cut value from building pad 0 and adding it to the cut value from building pad 1, and then the fill volume from building pad 0 and adding it to the fill value from building pad 1. So pretty simple and straightforward. The other dimension that's there, cut and fill, is the delta on that one pad. So there's 2 pads, so we take the delta from pad A and add it to the delta from pad B. It's just an order of operations thing for whatever is the expression that you're trying to write. So if I then wanted to grab either one of these measures and apply cost to it, I can do that. In my case, I'm going to oversimplify this, and I'm just going to take the fill less the cut, and then apply a dollar value to the soil that we need to truck into the site. So I'll add a new calculation, and I'll take a previous measure, which is the total fill volume. And then I'll get another measure, which is the total cut volume, and we'll say fill minus, right with emojis, James, it's fill minus cut multiplied by $5 a cubic meter. And I'll do some order of operations here, so this actually works. A less B multiplied by 5. And we'll call this cut and fill cost estimate. The unit is $1 dues and 50K. Probably underpriced this significantly, but that's where we're going to be right now. So then if I want to take that cut and fill estimate and add it into my expression here, that's relatively simple for me to do. I can go to total costs and add it in. We'll go add another component where cut and fill estimate is D, A plus B plus C plus D. Now that's considered as part of my scenario. So if we then said, okay, well, let's grade the park as well, see what happens if we have a perfectly flat park. I can say new building pad, and it needs to go all the way around the park. That cost is, now we're selling soil, so that's not entirely right. That's okay. We will elevate it up, and now we're at $4 million to elevate our park above everything else. It's not really ever going to happen though, so let's go back to our building pad, and we'll drop it down to be the same height as the apartment building. There it is. Okay, beautiful. $2 million to do that. So that's cut and fill, and I hope that shows you how you can use it visually. You can see the cut and fill numbers mathematically, and you can incorporate those into your pro forma to be useful from an estimation point of view. I'll pause there. Any questions or other features that we want to explore? No? Ollie, any questions on the chat?
Nope, chat looks all clear.
Okay. Well, I'll give it one more minute.